دكتور محمد، السلام عليكم.
وعليكم السلام ورحمة الله وبركاته دكتور عمر.
أهلا وسهلا بيك.
أهلا
والله
أهلا.
كانت محاضرة جميلة جدا. أنا عن نفسي استمتعت بيها جدا، وكان فيها معلومات كتيرة جدا جدا. يعني الواحد يعني حتة إن الهوريكين برضه يأثر على الفي تك برضه دي كانت أول مرة أنا أعرفها يعني.
شكرا جزيلا.
فألف شكر ليك يعني.
نعم.
Okay. So I have online questions about the second part of your presentations. We need to display uh, the difference between the southern and the northern part of Beirut expressions.
Yes.
There was a little bit time delay between the concentrations.
Yes.
The northern part was a little bit like faster than the southern part, isn't right?
Yes.
Yeah. So did you have any explanation for that?
Yes. Well, actually, as we have two explanations. We warranted this explanation, as I mentioned, by previous studies. Let me here. Here. There is a previous studies in 2018. It's concluded that there is ionospheric disturbance can travel with different velocities at different regions. This is the previous one, the previous explanation. The second explanation, according to my thought, it's related to the wave, because during the acoustic, the explosion, there is like acoustic wave or sound wave, and the other one is gravity wave. So you can see here, you can see my screen. This is the wave or the velocity. It's related to acoustic wave, and the other velocity, it's related to gravity wave. This is we are writing it in our article yeah, these days, and this under review. I think this is right suggestion, because it's different. For example, if you working on earthquake, the wave or the traveling disturbance, it will be more faster. So it's related the kind of wave affecting the ionosphere. Sometimes like seismic wave, like gravity wave. So it's related to the kind of the wave. You understand me?
Yes. Yes.
Yeah.
Very clear.
For confirm that, because the acoustic wave it happened fast after about 10 or 11 minutes. So it happened fast with the highest velocity. But the gravity wave, it delayed. It took more time. It happened after 20 or more than 20 minutes. So this is another confirmation to my suggestion. That's all.
Okay. Yeah. Thank you, Dr. Mohamed.
You're welcome.
Can I make a contribution to this? Because comment on this.
Yes, come.
Same topic, Dr. Mohamed. We know that the ionospheric disturbance is affected by the thermospheric. As you already done in the case of Typhoon, you measured the radial waves. Why you didn't do the same?
Was a Typhoon?
Yes.
Yes. Okay.
It was very interesting to know the directions and velocities of the neutral waves. That
Yeah.
we can such difference.
Yes. It's a problem related to the source of the event. For example, the explosion have only a specific point or epicenter we can know the location of it, and it's a fixed point. For example, like also earthquake. For earthquake, there is epicenter point. We can know the source of the wave. But for the typhoon, it's moving. The epicenter is multiple epicenter. It's moving with time. So we can't know the velocity. It's related to which point. This one thing, and the other thing, it's we in the Typhoon we working in VTEC, in vertical total electron content, because we have another study also related to Typhoon. We try to find the gap area because there is some study working with STEC and working on the day of landfall. The last day of Typhoon, so we're trying to cover the gap. The gap is the missing the day of the maximum wind speed to investigate the variation during this day. This is also the other one is because some studies using also GEMS, global ionospheric maps. So we try to use our regional ionospheric maps. So this is the thinking in the previous study. It's related to the event. Maybe we can manage or collocate the strategy to find the most convenient one to apply.
Other questions? Fine. So we can start the questions, internal questions from space 5 session. So who has a question? I think I expect a lot of questions. Okay, so when you have a question, please introduce yourself. Good evening.
Good evening.
I'm speaking from Kenya. Taking space environment and research. My research area is geomagnetic field, and I do geomagnetic physics, and I'm working on geomagnetic pulsation. Yes, I've seen there. If you go to the previous slides, I've seen some correlation between. If you look at the DST and the Kibi Index, I'm seeing there's some slight difference, and I'm trying to interpret that time frequency. You look at that panel, which is not.
Do you remember the number of slide?
It's up. Just go up a little bit. We talked about
Here?
It was before. No. Yes, that one. Look at that. You have this right, and look at the Kibi Index. The one that was having a red, and you are talking about Typhoon. Red.
You want the one related to Typhoon?
Yes.
Okay. This one.
Good. This one. Nice. Look at the ST index down here. And we look at this time going. UT going. I'm trying to ask myself, for that UT, is it the periodic? The periodic transfer, or what is it? Because now I'm trying to separate it with the KP so that I can connect with the Typhoon, because before you look at the Genesis studies, you are told that you can predict those Typhoon, those fast moving winds using satellite. And to know that it will occur at this point, at this bigger time, at this what. So I'm seeing therefore is this one is telling us the correlation between them, how we get, because I didn't get it there. My question is that clarified how is it detect typhoon?
I can't listen well, but I get maybe some point. Your point, you asking about Kibi index maybe associate to the variation or not, right?
Yes, yes, yes.
Okay. So we, as you can see, this is for Kibi index. It is from 0 to 9. This is a scale in general. And the values under 4, we can consider it as lower, and maybe up to 6, and we can consider as moderate value, and the 9 is a strong value. So if the value is under than or less than 4, we can consider this it is a steady state or the normal state for the magnetic storm. In this study, there is some days has more than this value, is about 6, especially for this day, 254. And this effect only on the day, not on previous or next day, on the day of the highest magnetic, because also this value is not for the whole day. Sometimes it's hourly value, maybe for 1 hour or 2 hours. It's not for the whole day. There is the Kibi index is 6. So for more investigation, you can find in which hour this happened to find it has some contribution or not. But we already exclude this day. We didn't take in consideration in our analysis when we try to find the average value, because as you mentioned, maybe it has association or it has effect on the value of ionosphere. So to avoid this point, we excluded. We didn't take in consideration when we calculating the average value. And this we can, if you remember, for the last method here, the last method we used the day for 254, which has it has a moderate or Kibi index about 6. It has variation more than the other station or the other days. So maybe this variation it's related to Kibi index. Maybe it's related to Typhoon. I'm not sure, but to be sure or not, you have to check which hour happened and which hour happened the variation, and compare with which hour happens the geomagnetic activity. Okay, but even with this variation happened, if we compare with the variation of Typhoon, it's insignificant. It's not big thing. Okay, but during the day for highest ionospheric variation, this day the space weather was stable in that day. So we can conclude during the highest variation, it is related to cyclone and not any random event like space weather or so. Did you get it? في دكتورة حسناء raised hand.
Okay, thank you for your presentation. It's very useful for me. And I don't know my questions are fundamental or not, but I need to ask. So the first one, how I can differentiate or separate between these effects and another ionospheric irregularities. So it can happen in a specific region or layer or specific parameters. This is the first question.
You mean you wanted to know in which layer the ionospheric disturbance happened?
No, I need to know how can I differentiate between irregularities and ionospheric. Let's say TID, TED. If I have signature for TED in the same area and at the same time we have explosion.
Yes.
So how can differentiate between them? How can know this signature in the data?
Okay. You mean there is some space weather indices, right?
Yes.
Yes, but in the same time we have was event like explosion or so. For example, as I mentioned in the first question, was I think Dr. Amr, you can find the velocity. If you find the velocity, we have different scenarios. The first scenario, you can check the specific time for the event and the specific time for the indices, because indices also maybe happen in a quarter of the day, not in the whole day, maybe in 3 hours or so. The second one, you can focus on the velocity. If the velocity, for example, in earthquake, it is larger velocity than the other effect like gravity wave or so. So maybe I can share with you something for velocity to know. Just there is a paper here. I think we have time.
Okay, these phenomena happen in lower atmosphere, lower region.
You mean the first one for cyclone? It was in equatorial ionosphere region. For Lebanon is like Egypt, mid-latitude region. It's Lebanon and Turkey in mid-latitude region.
Okay.
Yes, because also the sensitivity of the ionosphere is different in equatorial and also different than polar, and as you know, it's different than mid-latitude. Speed.
Okay, may I ask a question? Second question about is it moving across the different layers? If the first phenomena happen in the lower region, the lower atmosphere, is it moving across the upper atmosphere? And I can catch any significant in the data for this phenomena?
Okay, you're just, I need to, you mean there is two moving of the ionosphere. One is horizontal one and the other one is vertical one. Which one you mean?
Vertical.
The vertical one, yes.
Mm-hmm.
The ionosphere, as you know, there is multiple layers like D region or E region or F region. So according to the event, it's maybe arrive to higher ionosphere or maybe not. It's related to the powerful for the region, for the event. For example, if this severe, if this blast is not powerful enough, it will not arrive to the higher ionosphere. It depends on the event, and could be arrive from low ionosphere to the or bottom ionosphere to the higher ionosphere. It's dependent on the event. So it's possible to travel or transfer from the lower ionosphere to the higher ionosphere.
Mm-hmm. Thank you.
You're welcome.
It's a bit night right now. I know that Dr. Mohamed, I saw you that you are drinking a coffee to be wake up. So only one question more. So please, we'll ask. No, it was the old one. So will it
say your question?
Yes, I said the school. Okay, thank you. My name is William Rukundo from Uganda, and I am doing tech modeling, ionospheric modeling generally. Now, some of the few comments have been discussed, but just maybe two, but in a short time. One, you talked about VTEC and stake. Generally, by your experience, when do you use VTEC and when do you use stake? And which scenarios, and maybe you can just clarify on that. Then second thing maybe, I want to ask something about time delay. Because when you have an event, for example, you talked in the second case for the ammonium nitrate, Beirut explosion, you would show that there was a slide which I didn't pick the number, but when they were able to determine the disturbance at a certain, at actually 500 kilometers, I think by cosmic satellite. So, but in the first case, the Typhoon, what is the time delay? Did you look at something related to time delay? You get a disturbance in the ionosphere with the movement of, with the wind speed of the typhoon. Maybe you can clarify, and others I can maybe contact you personally.
Yes.
Then maybe another final question that I request that if accepted, you share with us the presentation.
My pleasure. Okay, no problem. I will revise it and then send it to Professor Ayman. He can sharing with you. No problem. So my
the
pleasure.
paper also, Mohamed, because we need to read your paper.
Also paper, but it's available. Yeah, it's more more details that will be in the paper. For your question, you ask when it is better to use the VTEC or STEC. I think VTEC is more easier to use. You can like mapping, you can mapping it will be easier. And but the problem, as you know, when you find the VTEC value, it's like overall behavior. It's when VTEC value is calculated, this is the value it's represent from different satellites. Maybe some satellites is infected or has some disturbance or not, and has some like crossing through a disturbed area or not. We don't know. But if you don't find some disturbance related to VTEC, you have to focus on STEC, because STEC, it's related to satellite by satellite. You can focus on each satellite. If you have like GLONASS or GPS satellite, all available satellite, you will find the specific results related to each satellite. Because, for example, you can see my hand. If the disturbed area here and another satellite, maybe the line of sight is not going through the disturbed area. But maybe, for example, this satellite number 2, this is satellite number 1, but maybe another satellite is only G22, for example, because we focus on all available satellite. The only one is G22 and G3. Only 2 satellites, we get disturbance from them. The other satellites don't have any disturbance because it's not crossing through the disturbed area. So in that case, it is better to focus on STEC value. Otherwise, maybe VTEC, it will be good in modeling, or maybe in severe event like solar storm. It will be has like severe event, not like typhoon, or not like also explosion. It happens in short time. But when you calculating VTEC, you will calculate it maybe every 2 hours, or maybe every 1 hour. If you follow the global modeling, it will be every 2 hours, like global ionospheric maps or GEMS. So temporal variation also, you can't discover it because it's happened for 3 minutes, only 3 minutes or 5 minutes. But you focus on 2 hours, so it's a sense to find the related temporal variation and the spatial variation. This is the backbone of this topic. You got my point?
Yeah, I get it.
Okay.
Okay. Thank you very much, Mohamed, for this interesting lecture.
You're welcome.
We are looking forward to first to see you here in Egypt.
We can cooperate before I return back. I'm looking forward to this. I'm looking for
the possible point that we can conduct our research together, and it should be our pleasure to participate. Because actually your research is very interesting and up to date, and many students here are very interested in your research. So I would like to thank you again. Send me the presentation and the 2 papers that you mentioned today.
Okay.
So we can deal with the other students, and if you allow me, some students would like to contact you personally. So I will give them your mobile number for contacting you through WhatsApp. Okay. Okay. Thank you very much.
Can we take group photo first? And I will send it to you, Ryan.
This is our case environment.
دكتور عمري اوكي دكتور عمري كان دكتور عمري please you can join us.
Some can come. The other people, please open your camera. So we will take group speed shot. Okay. Can we take it? Yeah.
One more. Okay, I will send it to. Thank you so much, and
I will share the course with all of you guys, and it will be our pleasure to be in contact Dr. Mohamed, and so just a start.
Okay.
شكرا جزيلا دكتور محمد.
العفو يا دكتور، فرصة سعيدة جدا ومتشكر جدا لحضرتك على الفرصة السعيدة دي، وإن شاء الله على تعاون قريبا يعني إن شاء الله. ماشي. فرصة سعيدة يا دكتور.
شكرا محمد.
دكتور عمرو، فرصة سعيدة جدا.
شكرا جزيلا. ألف شكر.
نشوفكم على خير إن شاء الله. السلام عليكم.
إن شاء الله. مع السلامة. السلام عليكم.
مع السلامة. مع السلامة.